Good morning, everyone. I'm Adrienne Esposito. I'm the Executive Director of Citizens Campaign for the Environment. Thank you so much for coming to our Climate Change Symposium here in Earth Month in 2025. I can't believe I have to say this in 2025, but climate change is real. The Earth is round. The government is not manipulating the weather. Gravity's a real thing, and climate change is here. Okay, those are some facts. The reason we're having this Climate Change Symposium is because facts matter, the truth matters, and science matters. And there are so many myths out there. There's so much misinformation out there that we believe it's important to also put forth facts and truth and reliable information. You know, people are really bombarded, all of us, right? We're bombarded by all this information, 24 hours a day, 24-hour news. You get your news from social media. There's TV, there's print media. That poor print media is going out of business. But there's radio, there's all sorts of avenues for news. But not all of it is right or correct. I saw someone shake their head. Yes, good job. A lot of the news, unfortunately, is motivated by political science rather than biological science. And that's where we have problems. And we see this all the time in our work. I mean, we are an environmental organization. Some people call us environmental activists. But our job is to work to protect clean water, clean air, and the natural world. And one of the greatest challenges is climate change. And the most myths out there are about climate change, followed closely by renewable energy. Who has seen a post here about renewable energy is a scam? Wind power oh God, everybody. Wind power kills whales, which is false, 100% false. It costs more money to build a wind farm it uses more energy to build a wind farm than they'll ever produce in their lifetime. False. All of this information out there is directed to confuse the public, misinform the public, and support the continued addiction and reliance on dirty, dangerous, antiquated fossil fuels. That's what this is about. It's not a news informational issue. It's a campaign. It is a public relations campaign by oil and gas and energy industries who want to keep those industries alive as long as they can, no matter the damage to the earth, no matter the damage to your health, and no matter the damage to our oceans, estuaries, air, and drinking water. Well, we object, and we're fighting that because clean energy does work. Wind does work. Solar works. Are we going to be able to rely on it 100% tomorrow? No, and we know that. And we're not saying that those energy sources are perfect. They are not perfect. What we are saying that given the choice between burning fossil fuels or using clean energy like wind and solar win. Wind and solar have the least impact on our environment. Fossil fuels have the greatest impact on our environment. And that's the choice today. We're making a choice. Fighting climate change, transitioning to renewable energy, and working so that clean power replaces our dirty fossil fuel power plants. We are so excited today to have two wonderful speakers with us. Our keynote speaker, Dr. Paul Shepson, comes to us from Stony Brook University. He is the dean of New York State Stony Brook University's Atmospheric and Oceans Division. And he has a wealth of knowledge on these issues. So in the spirit of facts and science are important, I'm turning the mic over to Dr. Paul Shepson from Stony Brook University, who's going to talk to you about what are the facts regarding climate change. Dr. Shepson, thank you so much for joining us.
So I've always thought that applauding before you hear the talk is a form of prayer. I'm a scientist, I'm not a religious man, but good luck to you with that. I really hope it works. We don't know. Anyway, this is a nice, friendly crowd here, a good group. If you can, move forward so that we're all together. And in the spirit of that, I just want to say, there aren't two sides. There's all of us together living on this planet. We all share this particular problems and all environmental problems. And we should solve them together. So in the spirit of we're all friends, we're sort of a family here on Long Island. If you like what you hear, you're allowed to cheer wildly. If you don't like what you hear, you can throw stuff, yell stuff. You can do that. We'll clean, Adrienne and her team will clean up afterwards. Raise your hand, yell out, it's fine. That's our wonderful planet, the really only one that humans will ever have from now until the end of all time. No one is ever going to live on a different planet. We can't trash this one. It's not oval like that. It isn't flat, but it's also not oval. On the screen, it looks pretty circular. Anyway, weird projector. So I'm going to talk about some of the facts that Adrienne referred to and a little tiny bit about science. There's a difference between facts and science. And I'm going to try to end with some hope. So first, I want to give you facts about what human activities have done to the Earth's atmosphere. I'm going to be talking about greenhouse gases, largely carbon dioxide that comes from burning fossil fuels. We can determine the history of the atmosphere's concentration of carbon dioxide from a variety of proxies, but we measure it directly from air bubbles extracted from glacial ice. So this is a record from an ice, can we?
You're too close.
It's not, we don't want both mics. I don't know how to turn that off. This is the concentration of carbon dioxide in the atmosphere going back 800,000 years. Here's when Homo sapiens appeared, roughly. It has varied between 200 and 250 parts per million. And then here's the start of the Industrial Revolution. And so since way before the dawn of man and woman, carbon dioxide is at concentrations that we have not seen before. Millions of years ago, it was higher than that, and it was a lot warmer than it is now. We have been measuring carbon dioxide in the atmosphere directly by sampling the air since 1958 at a variety of places, but first at Mauna Loa in Hawaii. So it was at the start of the Industrial Revolution, about 280 parts per million. When we started measuring it, more like 315. And it has gone up to where it is now at about 426 or so. You see the little annual wiggles, the size of which tells us about the biosphere. You can also see that the rate of increase is increasing. And I can show you that a little more quantitatively. This is just a calculation of the year-to-year amount of increase of carbon dioxide in the atmosphere. I just remembered I wanted to tell you that we know that all of that increase comes from burning fossil fuels, period. Because the fossil fuels have been in the ground for millions of years, many, many lifetimes of carbon-14. There's no carbon-14 or radiocarbon in the fossil fuels, the carbon-14 in the atmosphere has been diluted by the addition of what we call dead carbon, that is only carbon-12. So this is how we're changing the composition of the Earth's atmosphere dramatically, and we know that it's all from burning fossil fuels. So back in '58, the annual increase was about 1 part per million out of 320 or so, and now it's increasing at over 3 parts per million a year, and that is the rate of increase is increasing. And we're doing that now intentionally. The United States, for better or worse, has decided that we should add a lot more. And we have the help of multinational corporations like BP and Shell have said we're going to stop investing in renewable energy and we're going to invest more in fossil fuel production and development. So the other important anthropogenic, meaning from people, greenhouse gas that's important is methane. It comes from bacteria, anaerobic bacteria, for example, that exist in landfills. It comes from using and spilling natural gas and from wetlands. So this is from ice core data. It used to sort of vary around 500 parts per billion. Here's the start of the Industrial Revolution. This is the impact of humans. 3 times as much as there used to be before humans were around. Here is the last 30 years of increase of methane. It was actually flat around 2000 and then started increasing for a couple of reasons. One is the advent of fracking to produce natural gas. And the other part is that the planet is warming and the production of methane from anaerobic bacteria is exponentially temperature dependent. So there's a positive feedback in the system that is making the Earth emit more methane. So for methane, same thing. This is the increase. It's in parts per billion. 40 years ago, it was about 12. It has been increasing since this relatively flat period, as I said, because of fracking and because of increases in emissions mostly from wetlands that are warming. So this is a plot from the NOAA Global Monitoring Laboratory about the relative importance of greenhouse gases that are emitted by humans. About 2/3 of the total that it is causing global warming is coming from carbon dioxide, about 10% or so from methane, a little bit from agriculture, from nitrogen fertilized fields produce nitrous oxide, and a little bit from chlorofluorocarbons. You should know that the greenhouse effect is caused by water vapor, carbon dioxide, and methane. It's totally natural. Without it, the water on the planet would be frozen, and we wouldn't be here at all. So the greenhouse effect is totally natural. We're just adding to it, and here is the relative importance of these gases. Water vapor is really important. As we heat the planet, water evaporates from the surface faster, so the amount of water that's in the atmosphere is also increasing. But there's good news, and I want to spend time talking to you about good news. So I said that chlorofluorocarbons, here they are right there, are important greenhouse gases. They are refrigerants. We used to use Freon 11 and Freon 12 in refrigerators, in automobile air conditioners. But it turns out that a bunch of scientists working in Antarctica measured ozone in the stratosphere from the surface of Antarctica and discovered the Antarctic ozone hole. And it was discovered and proven from experiments that the photolysis of chlorofluorocarbons, like this one, dichloro-difluoromethane, produce chlorine atoms that destroy ozone and would threaten millions of people with exposure to ultraviolet light that would cause skin cancer. And that is happening. The incidence of skin cancer has increased because of this problem. But in this case, everyone in the world decided this is bad, this is scary. Why don't we all work together? There aren't two sides here. There's just us wanting to not die of cancer anytime soon. So in 1990, so the science happened in here. In 1990, everyone met, scientists and policymakers met in Montreal and created the Montreal Protocol, and everyone on the planet agreed that we're not going to make these compounds anymore. There are some who started making them again recently, but mostly, and in the United States, we are not, and the atmosphere is responding. So this is an important story. When we're faced with a problem that we can all recognize as a problem, we can solve it. It's easy, sort of, quote unquote, easy. We know how to solve the climate change problem. We just need to never think that there are two sides. We all live on the planet together. Whoops. So I need to quickly explain the greenhouse effect. It's kind of easy. The sun heats the earth. You can see it, so it's absorbing visible light. It warms up, and so it then re-radiates that additional heat out to space in the form of infrared radiation. So it turns out that greenhouse gases are greenhouse gases because they absorb infrared radiation. The most important one is a water molecule, H2O. So imagine that this is a hydrogen atom, and this is a hydrogen atom, and here's oxygen. So water molecules sit out there going like this. If they absorb an infrared photon that comes from the surface of the Earth or from anywhere, they absorb it and they might start going like this. And the water molecules say, well, my arms are getting really tired. I think I want to relax, and it relaxes by emitting an infrared photon, and all of a sudden now it's going like this. A photon comes out, it's in the infrared. The molecule is spinning around in space, and when it emits that photon, it can go in all directions, like towards the surface of a sphere. Effectively, half of the time that emitted photon goes up. The other half of the time it goes down and it hits the Earth. And so because of those greenhouse gases, the surface of the Earth is impacted by more energy, more radiation than it would if the greenhouse gases weren't there, and the surface of the Earth is then warmer as a result. That's all there is to it. Water and CO2 and a little bit of methane makes the Earth habitable. Without the greenhouse effect, you would not be sitting there. So the result of having more of them is more of what I just described is happening, and the surface of the Earth gets warmer. It is physics. It has nothing to do with politics or two sides. No matter what you think, those molecules will absorb that infrared radiation. You can't stop it. If there are more of them, they will absorb more and re-emit more down to the surface. So the result is totally predictable. It was predicted in the middle of the 19th century by people like Joseph Fourier in France because they understood physics. So it is happening. This is a plot of global average temperature from 1860 to the current time. You know that last year was the hottest year on record. The global average surface temperature has increased by 1.6 degrees Celsius, or a little more than 3 degrees Fahrenheit. For just the solid surface, it's more like 1.8 degrees because the solid surface warms more because it is relatively darker. 90% of the excess heat from the greenhouse effect is stored in the oceans. So the oceans are warming. This is the change in temperature of the surface of the ocean. Over the past 24 years, it has gone up by something like 0.8 degrees Celsius. A lot of the heat mixes down, so how much it has warmed, it's just a different sort of problem than warming the surface of the Earth. But there's no question that the oceans are warming. That impacts the fish populations along with overfishing. But it also makes water evaporate faster. So Newton said what goes up must come down. If water goes into the atmosphere faster, it is absolutely required that it rains faster, that it comes back down faster. So we are having more rainfall and more extreme precipitation, and you guys are living through that. You know, if you've lived here all your life, you know that that's the case. So the amount of water vapor that you can have in the atmosphere depends on the atmosphere's temperature. Higher temperature, it can hold more. That's exponentially temperature dependent. So here are observations from satellites and other measurements within the atmosphere of the change of humidity. This is over the last roughly 40 years. So the average humidity of the atmosphere, the amount of gas phase water, has increased by about 7%. That water vapor is a greenhouse gas, so that's a positive feedback because water is such a potent greenhouse gas. So I hope that the person I referred to as Uncle Bob is here. Uncle Bob is angry that we're having this conversation. And as I said, no matter how angry or happy we are to hear what I'm saying, it's happening. You can't change the physics with your mind. I don't think, if you can, you might be able to be rich. Let me know if you can. So I've been talking about observations, about facts. Now that's different from science. That's not science. Science is about asking a question about nature, about the world, about living things, and then designing an experiment to test a hypothesis. So there has been a hypothesis for about 175 years that adding greenhouse gases to the atmosphere would warm the atmosphere. So I'm going to just tell you about one experiment. It's an experiment done with computers that are coded to simulate the Earth and all of the processes. The uptake of carbon dioxide into plants, the respiration from plants, the circulation of ocean water, the amount of sunlight that comes into the Earth, how much that is changing, and so on. So climate models, or we sometimes call them Earth system models, because they don't just simulate climate, they simulate the weather and climate, which is average weather, and all sorts of things that are happening, like changes in the Gulf Stream. So here's a plot of the change in temperature over time from various proxies and then from thermometer-based observations. So why are we, is this?
When you go up there, don't go up there. Right?
Oh, okay.
Yeah.
So change over an average in this period, right around here, 1788, was when the Constitution was written. You guys remember the Constitution, right? An important document. And right around here is the start of the Industrial Revolution. So as I said, about 1.5 degrees Celsius. That's how temperature has changed. We know that to be true. Now we take our models, Earth system models, and we simulate things like, why is the temperature what it is, and is it changing? So in this experiment, we have two models. One that ignores human activities and the emission of greenhouse gases, but it takes into account all of natural changes. Especially, I often hear from Uncle Bob, what about the sun? It's changing. No, it isn't. And it isn't. We've been measuring it. We have satellites out there that show that it's not changing. But anyway, you put all that in there and you get You get this green line here. The black line, the heavy black line, is the observed temperature change. So if you simulate only the natural variability, you get this green line, I think it's green. I have to be careful where I stand. And then the average is the heavy green line, and that's the variability between different scientific groups' models. So it's sort of the variability, the uncertainty in our understanding. Now when you add the human component, you run the same model, but you just add the change in greenhouse gas emissions, you get the light brown line, and you can sort of see the light brown shading. That's sort of our estimate of the uncertainty. The two uncertainty bounds don't overlap. This is a statistically significant result. There is just no way to simulate temperature change without greenhouse gases, and if you include them, you do simulate it. We understand it more or less perfectly, really perfectly enough to get to the question, okay, we have a problem together, all of us, independent of your politics. Do we want to do anything, and what can we do? So that is an example of science. As I said, you guys are experiencing climate change about 3 degrees Fahrenheit, again, about 1.6 degrees Celsius over the past 120 years. You can actually feel this and see it. Some of us are skiers. The ski season is shorter. This breaks my heart. That's the entire reason to fix this problem. So why do we care? What are the impacts? One is if you warm the ocean, the water expands, it becomes less dense, it occupies a greater volume. This is observations of sea level over the past 140 years. The black line is satellite-based observations, and the blue is measurements from the ocean, from the coast, from everywhere, averaged. And the satellite and the physical observations from scientists agree. So this is just 10 inches, something like that, over all of that time. But it's going to be more like 3 to 7 feet, something like that by the end of the century. Some of you will be here at the end of the century. Do not buy homes on Fire Island. Fire Island will be gone in your lifetime, etc. So this is a problem for some of our wealth that is expressed in coastal properties. Another thing is heat waves. You hear about heat waves. There's a paper published in the Proceedings of the National Academy of Science 15 years ago saying, be careful about how warm we allow it to get. If the wet bulb temperature, and that's sort of a measurement of temperature that takes into account humidity, gets to 35 degrees Celsius, your body's perspiration is no longer effective in cooling you. So if you live in an apartment building that doesn't have air conditioning, there's an example of climate justice or environmental justice issues. You will die if you're exposed long enough. So they said, well, the wet bulb temperature never exceeds 31 degrees Celsius. That was 15 years ago. But recently there have been 1,000 or so instances where that is not true, and some observations near the equator where the 35 degrees Celsius threshold is observed. And then now all of this is peer-reviewed literature. This is from newspapers. It happened in 2024. Lots of heat waves in the United States. Palm Springs, California got up to 51 Celsius. That's the actual temperature, not wet bulb, but that's hot enough to kill people. Redding, California, 119 Fahrenheit, 48 C. Phoenix said 13 heat-related deaths in 2024. I did not confirm that. Las Vegas hit 120 Fahrenheit. So this is happening. When we have a heat wave in New York City, people, hundreds of people, die from the heat wave. Now, an individual event isn't climate change, it's weather, but it's on a background that's higher in temperature than it used to be. So a paper, peer-reviewed paper, boy, it's really hard to control this stuff, appeared in the Journal of the American Medical Association in 2024, saying that heat-related deaths have increased by more than a factor of 2 over the period 99 to 2023. Here's a plot of the estimated frequency of heat-related mortality or heat-related deaths. So in the past 10 years or so, there has been a spike because you don't die when the temperature is significantly below, some threshold. And when you're exposed to temperatures as high as 35, then lots of people die. I'm not saying climate change is going to kill everyone, but it is killing some people. Sometimes Uncle Bob comes up and he says, "You said that we were going to die from cancer." What? No. Anyway, we need to communicate more as a team. Just really quickly, there's a phenomenon that you can observe called hydroclimate variability. So we are experiencing more frequent shifts between extreme precipitation and extreme drought. And so this is a plot of the frequency of what's called climate whiplash, a conversion from very wet, lots of precipitation, to very dry and back again. This is what climate models that are not perfect say is going to happen, that this will happen. These are our observations, so it's happening faster than was predicted. As I said, there's more water going into the atmosphere, so precipitation is increasing. This is the last 130 years for New York State. Precipitation is increasing by 0.06 inches per decade. Doesn't seem like a lot, but it's been warming by that much for over 100 years, and so it has become significant. Let me express it in terms of the frequency of extreme precipitation. So you guys know, we know that we've had cases in the last few years where it has rained like 7 inches, 9 inches in one day. Here's a plot of the change in the frequency of days that have 5 or more inches of rain. This is for the Northeast. So the Northeast is experiencing the most intense changes in precipitation in the United States. So for 5+ inches, it has doubled since 1958. So over the last 100, whatever that, I can't do math, 170 years or so. Lots of days, the numbers up here around 10 to 20 days with at least 5 inches of precipitation. I used to be able to do math. So on average, the planet has warmed 1.6 degrees Celsius, about 3 degrees Fahrenheit, but it's about 3 times that much in the Arctic. And that's because of sea ice. When you melt sea ice, you change the surface from reflective to one that's the blue ocean, and that absorbs more sunlight. So climate change is melting sea ice. This is a plot of the volume of sea ice versus time. So the slope here is equal to 290 cubic kilometers of ice going away per year. Does that bother you, affect you? Maybe not. I mean, it would be a problem if you were standing on the ice, but there are a lot of beautiful forms of life in the Arctic, and their habitat is at risk. So here's here's 2 forms of life in the Arctic. Inupiat Eskimos, who are subsistence hunters who live along Alaska's north coast and all around the Arctic. This is a bowhead whale. This one was about 40 tons. This will feed the whole town of Barrow. It's now Utqiagvik. It'll feed the whole town for several months. So this is a significant part of their diet. They have a religious relationship with the animals that they kill for food and never kill any more than they're going to eat. And man, do they use every single part of this whale. Now, the bowhead whales have a natural predator called the orca. The orca tries to eat them. The bowhead whale swims away, and it swims under the ice. The reason is bowhead whales have a bowed head. It has a bony skeletal structure that allows them to smash a hole in the ice. So if they can just outswim the orca runs out of air and it's got to turn around and go back to the ice edge to breathe, and the bowhead whale does that. So to me, those animals are just, they're remarkable, they're beautiful, we share the earth with them. But someone has to advocate for them because they don't have the ability to advocate for themselves. Polar bears have their dens on the ice. They raise the little cubs on the ice. Seals have dens on the ice. They raise the little seal pups on the ice near a hole where they can get away from the polar bear. If they can't hide from the polar bear under the ice, they get eaten. If the polar bear loses the ice, it loses its home, its ability to have a safe place to raise their pups. So this is a problem. Here's another problem. So here is Greenland, and this is a plot of the total loss of mass of the Greenland glacier. In the middle of Greenland, it's 2 miles thick ice, and it's melting at a rate that is increasing. So far, more than 5 trillion tons of ice have been more or less permanently lost. If it were me making decisions, I would ask the question, do I want to own this property? No, not sure that it's a good idea, but I'm not thinking of, military things. Anyway, we need to think about the rights of the people who live in Greenland. You also know that when you have heat waves, if there's drought for a long time, in forested areas, the leaf litter, small bits of wood on the floor of forests dry out. If it's a pine forest, the needles are extremely flammable. They're basically full of gasoline, pine needles. They're amazing. So here's a plot of the annual average for 2 time periods, 84 to 2002, millions of acres of forest burned in the United States, and then 2003 to 2021, twice as much. So we are seeing, and you read about it in the paper, but there is actual data. It's important to use actual facts. This hits home for Stony Brook University. We have a beautiful research station in Madagascar in Ranamafana National Park. There's not so much rainforest left in Madagascar, but that rainforest is home to lemurs. Madagascar is the only place on the planet where lemurs have a natural habitat anymore. So around January of this year, there were wildfires for the first time ever to recorded human knowledge that there have been forest fires in the rainforest in Madagascar. So that threatens these amazing creatures that don't have any natural predators. You could go there if you're dying to spend some money. And walk right up to these lemurs and interact with them. They don't have a natural predator, so they're not scared of you. And their habitat is going away because of us. Do we have a right to wipe out entire species like bowhead whales? We need to think about that because they can't advocate for themselves. We're smarter than that, right? We're supposed to be. So we should stop. This is just an opinion. I think it would be a good thing to stop warming the planet. So in principle, it's easy. We stop emitting those 2 greenhouse gases. This one comes from landfills. We should control our organic, our food waste, and we should stop mining natural gas if we can. It's sort of an addiction, and we should stop burning things. So how do we do this? We stop burning things. Stop burning things. It's as easy as that, except we are, like addicts. We love it. So what are we, excuse me, what are we burning? Do you guys have a hook?
Not yet, but soon.
You're gonna need a hook. I'll try to go fast. So here's what we're burning versus time. This is oil. The blue one here is natural gas. Since we learned about fracking, it has taken off. This is coal. Coal is too expensive. We're stopping the burning of...
It's coming back.
What's that?
The president said it's coming back.
Oh, well, yeah, but it's all about money. So if coal is more expensive, it does not matter what Donald Trump says or you say or anyone says. We're not going to burn coal anymore. We're producing natural gas. It is cleaner, but it's, like calling it clean dirt. It's cleaner than coal. And here's nuclear. We're not going to build any nuclear power plants, because they're expensive. And then here come renewables, sort of a gift from Earth or God or whoever you want to attribute it to. So here is a plot over the past 35 years of greenhouse gas emissions by the greenhouse gas, mostly CO2. The total is going down entirely because of that one, entirely because we're not burning as much coal because it's more expensive, and burning coal emits more CO2 than burning natural gas by about a factor of 2. It's not that we're trying really hard, it's that we want to make more money. So this is greenhouse gas emissions by activity, transportation, airplanes, cars, the Long Island Railroad, etc. Keeping the building lit and heated and cooled and so on, industry, agriculture, commercial and residential heating and cooling. Now I want to get to this slide. Who is guilty here? Anyone want to raise their hand and tell me who is guilty? Aren't we all? Yeah, you should come up here and give this. Yes, but here's some facts. The annual amount of CO2 emissions by country. Here's the United States. Way down here is various European countries. India is growing, but here's China. More than twice the rate at which we are emitting. But carbon dioxide has a couple 100-year lifetime in the environment. So essentially, it's half, because half of the CO2 that we emit goes into growing forests and dissolves in the oceans. But the other half stays in the atmosphere roughly 200 years. So everything we've ever burned, half of it roughly, is still in the atmosphere. So what really matters is the total amount. So here is the cumulative amount of CO2 emissions by country. The United States, way above second place, which is the EU. In third place is China, but look at the slope. They're going to catch up with China in a few years, maybe 10 years. They'll catch up with the United States. So it's really North America, the EU, China, India is coming along, but really it is what you said. It is all of us. We all share the planet. We're all burning things. We need to all stop. And of course, there's a huge amount of money to be made in the alternative if we're going to change the way we do everything. So Stephen Hawking, who's a reasonably smart guy, said, look at the data, isn't it scary? But wait, if you meet people who are working on this problem, you should be really optimistic. So what's being done? I'll be really quick here because I'm running out of time, like 2 minutes. There is still an IRA tax credit for residential solar, and in New York State there's that plus the federal tax credit for buying an EV. Donald Trump wrote an executive order, but it has to be approved by Congress. So you can still invest and save money on your taxes. So just quickly, what's happening with electric power production? This is the total from natural gas, from coal, it's going away, nuclear, we're not building any. So really the future is about renewables. Donald Trump likes to tell you how to invest. I'm going to tell you that solar power is maybe a good long-term place to invest. Here is just the renewables. There's the growth of wind power. This is solar, just growing exponentially. Hydro, well, how many dams can you build? Geothermal should be doing better than that, but solar is taking off. Why is it doing that? Because it's getting cheaper. This is a plot of the efficiency of solar panels. Used to be 45 years ago, 10% efficiency, meaning what fraction of the energy in the sunlight that strikes the panel is converted to electric power. Now it's about 26%. So that makes them cheaper. This is just the past 10 years. The price of solar panels has dropped by a factor of 3. So the payback for you investing in solar panels on your house, if you can do that, is great. So this projector does not do yellow. There's a yellow one. That's utilities, and it goes like this. So utilities are investing in electric power from solar, and also residential is growing and commercial. People are doing it. Individuals can make a difference. So in Southampton, there's the town of Southampton Sustainability Committee or something like that. And they know that some people, like my wife and I, cannot put solar panels on our house because the roof is very steep and our house is surrounded by trees. But the town can invest in community solar. So what they did is create a solar farm, 4.6 megawatts, on the top of a town of Southampton defunct landfill. So this is called the North Sea Solar Project. Everyone in Southampton now pays less for their electric power because a few people said, let's do something. We now have offshore wind. I don't know if it's a great thing. The world built 132 megawatts of offshore wind east of Block Island. You might like it, you might not. There's a trade-off in what we do. We are maybe industrializing the oceans, and I kind of like wind power on the
prettier than oil
land. You can't see these, but fish can. So we need to know what the impact is. So what can you do about it? You can do less of that. If you calculate your own carbon footprint, a significant part is probably air travel. Wear a sweater in the winter and run around in your bathing suit in your house. Do whatever you want to when you're by yourself in your house. Do you need a car that we could use to invade Canada to get to Stop and Shop? I mean, with just one of those, we could probably take over Canada. They say, yeah, whatever, I don't do what you need to. People don't realize the things that we do that use electricity and put CO2 in the atmosphere, like using the elevator, is really significant. Ask yourself if you need to take the elevator down at the end of the day. How does the button open the door? The button doesn't open the door. There's a box above the door with an electric motor in it. Every time, if you're handicapped, don't take my comments personally. A lot of people who aren't handicapped do this. You have no need for that. So you can install solar power on your roof. You can have a battery in your garage that might ignite and burn your house down, so maybe in your garage is not a great idea, but you can have storage for your house. So there is hope. What I'd like to say is great things can happen and have happened with great leadership. I'm just going to give you an example of something that feels really hard. So JFK said in 1961, we're going to go to the moon. We're not doing it because it's easy. We're doing it because it's hard. Because we like to work together on a challenge. So don't tell us it's too hard. In the summer of '68, the Russians sent a unmanned, unwomaned capsule to orbit the Earth. And we panicked in August of '68. We did not have an Apollo 8 plan. We didn't have a crew. We didn't have the hardware. Nothing. In August, they decided we're going to do this, and it all got planned and executed in 4 months. We can't buy a military toilet in 4 months, but it can be done if you have inspiring leadership, like we seem to have in Southampton. So the result is Earthrise, one of the most famous pictures in all of human history. 57 years ago, nobody owned a calculator. We had slide rules, you remember? So the future is bright and exciting. We can do this. We just have to choose to do it. So there is hope. The future is bright. You can do it. You can make an impact. Thank you. And I went a little over. I'm sorry. That's what I do. It's really new.
Thank you so much, Dr. Shepson. That was wonderful. And, you know, we learned that climate change is real. The Earth's temperature is actually warming up. We also learned that 90% of the carbon dioxide is going into the ocean, warming the oceans, which is bad. And we can fix it, though. So here to tell us also, what does that all add up to? How is it impacting us right now? Does it cost us any money? Yes. Yes, it does. So to answer those compelling questions that I know you are asking yourself, we have with us today Dr. Bret Bennington from Hofstra University. Dr. Bennington is a professor and also the director of the Geology, Environment, and Sustainability program at Hofstra. So we're very fortunate to have you. Come on down.
Thanks for coming, and thanks for sitting through two presentations. I will try and get through mine pretty quickly here. Let me tell you a little bit about myself. I'm actually a paleontologist by training, and so I have an interesting perspective on the state of the planet. I have a very sort of deep time perspective. We're currently going through the 6th mass extinction, mostly because of human activities and habitat loss. The Earth has been through 5 other mass extinctions, and it always comes through. And if you give evolution a few million years, it makes new species, and the Earth goes on. So I'm not too concerned about the fate of the Earth. The Earth will do what it does and keep doing it probably for about 3 billion more years until the sun puts an end to the show. I'm primarily concerned about us, right? We're not going to destroy the Earth. We're going to destroy ourselves. That's really the issue here. So what I'm going to talk about is climate change from the perspective of what is it doing to humanity? What is it costing us? There we go. So let's start with a quote from our new Secretary of Energy, Chris Wright. He gave a talk in England about a month ago, and this is what he said. He said, "The Trump administration will treat climate change for what it is, a global physical phenomenon that is a side effect of building the modern world. The Trump administration will end the Biden administration's irrational, quasi-religious policies on climate change that impose endless sacrifices on our citizens. The previous administration's climate policies have been impoverishing to our citizens, economically destructive to our businesses, and politically polarizing. The cure was far more destructive than the disease. So there's a couple of interesting things to point out here. This is actually kind of encouraging, because when I first started teaching about climate change over 20 years ago, the opinion coming out of, or the viewpoint coming out of the fossil fuel industry was that climate change wasn't real. It wasn't happening, right? And then that evolved to, well, climate change is happening, but it's not our fault, where we can't do anything about it. Now you have a representative of the fossil fuel industry, somebody who has made a substantial career dealing in natural gas, basically saying, yeah, climate change is real, but it's a side effect of having the civilization that we have. So let's think about that. You know, how bad is the side effect? How destructive is the disease of climate change, and can we just sort of write it off as a side effect? The other thing I find heartening about this is that it seems to suggest that the Trump administration is very concerned about causing economic disruptions. Makes me feel a lot better. So as we learned in the last presentation, excellent presentation, the problem with climate change is that it puts more heat into the atmosphere, which means there's more energy in the atmosphere and more water in the atmosphere. And this leads to more extreme weather events, thunderstorms, which are often referred to as SCS, severe convective storms, tropical cyclones, aka hurricanes, tornadoes, floods, hail, drought, and wildfires. So these are the atmospheric manifestations of the Earth's climate. Now, how do you sort of do the accounting of climate events? Well, the National Oceanographic and Atmospheric Administration and the world's insurance industries use a metric of billion-dollar events. So basically, any climate event, any storm that causes over $1 billion in damage is a billion-dollar event. And just to provide an example, 2024 was a pretty good year for billion-dollar climate events. There were 27 billion-dollar climate events, including, let's see, no laser. So the little circular things with tails are hurricanes, and I've listed the hurricane scale, the Saffir-Simpson scale values. Thank you, sir. So Hurricane Beryl was a Category 5, Francine was a Category 2, Milton was a Category 5. So it's a pretty good year for hurricanes in 2024. So you can sort of count up billion-dollar climate disasters and use that as a metric for kind of assessing the cost of these climate events. So here's a graph. I'm going to show you a bunch of graphs here. Here's a graph that shows sort of how billion-dollar climate events accumulate through the year. And they add up kind of steadily from January to December. And then you can see which years had the most number of billion-dollar climate events. So 2023 is the winner with 28. 2024 came into a close second. 2020, 2017, 2021, 2022. And then, all the other years are encompassed in this line down here. So you get a sense that billion-dollar climate events, the years that have the most billion-dollar climate events are years that have happened in the recent past. All right, let's look at another way of sort of looking at the data. If billion-dollar climate events are increasing, which types of climate events are increasing the most? So this graph is showing the increase from 1980 to 2024 in billion-dollar climate events categorized by type of climate event. And one thing that sticks out here are the green bars have increased substantially, and those are severe storm events, so thunderstorms. The frequency of thunderstorms has and the severity of thunderstorms has increased a lot through the 21st century here. There have also been increases in some of these other events, but the thunderstorms sort of really stick out. And then here's a graph that shows cost, right? So again, the accumulating cost of these different events in billions of dollars. And again, the years that stick out are these years from the 21st century. 2017 was a banner year. 2005 was also a big year. Anybody remember the natural disaster 2005? Katrina, Hurricane Katrina, right? Very good, very good. 2024 is up there. And you can see that starting in July, the costs increased pretty dramatically, and that's because that's hurricane season. So hurricanes, as individual billion-dollar climate events, tend to have really, really big price tags because they're such large storms relative to, a line of thunderstorms crossing the Midwest, which has a smaller footprint. So you can add up all of these billion-dollar climate events by category, number of events, the CPI-adjusted losses, so the cost of the events. And all of these data, by the way, are adjusted to the consumer price index. So you need to, because of inflation, if you want to compare a billion-dollar event from 2020 with a billion-dollar event from 1985, you have to adjust for the fact that inflation has happened. And so it's harder to get to $1 billion in 1985 and easier to get to $1 billion in 2020. So the way you do that, basically, is you kind of compare the cost of goods between those two time periods. So let's say if a quart of milk cost $1 in 1985 and it costs $2 in 2020, then you have to take the cost of a disaster in 1985 and multiply it by 2 to get the equivalent cost. So the point is that we're comparing apples to apples by normalizing the costs for based on the consumer price index. Anyway, so what the data shown in this table are billion-dollar events from 1980 to 1999. So that's a 20-year stretch of time at the end of the 20th century. And if we look at the totals, so there was a total loss of $433 billion over that 20-year period. Average cost of about $5.5 billion per event, and 79 billion-dollar events. Now let's look at the data for the 20 years of the beginning of the 21st century. So if we look at from 2000 to 2018, 162 billion-dollar events, $1.2 trillion worth of losses, and average cost of each event up to $7.6 billion. So if we just go back here, right? So 79, 433, 5.5 to 162, $1,238 billion and $7.6 billion. So the total cost has basically tripled. The number of events has essentially doubled, and the average cost per event has almost doubled. So there's been a big increase in the amount of money that these climate-related disasters are costing. Now, why is everything increasing? Why is the cost and the number and the average cost per event of climate disasters increasing? Well, there's a number of things going on here. So one is the fact that the value of property is increasing. As a nation, we are steadily becoming wealthier overall, so we're building more expensive homes, bigger homes. So there's an event that causes destruction is destroying a larger amount of more valuable property. There's more population, and population is spreading out so that you're putting more people in harm's way, essentially. Instead of having population being concentrated in a few places, cities, the population in cities across the country is expanding out into suburbs and into rural areas. And there's also been a big shift in the United States in the population towards areas that are more vulnerable to climate events. A lot of people have been moving to the Gulf Coast, for example. And the Gulf Coast region is susceptible to severe thunderstorms and also tropical cyclones. And then finally, there's climate change, right? So these events are being made more powerful by the Earth's climate. And the climate change interacts in a positive way, or in a constructive way, well, actually a destructive way, I should say, with these trends in population, right? So you're putting more people and more property in harm's way, and the harms are becoming larger and larger and larger. Case in point is Florida, right? So over the last 10 years, the population in Florida grew by about 7 million people. And the people who are moving to Florida tend to be older, wealthier people. So the sort of net value of homes in Florida has been increasing, and retirees who have a lot of money like to live on the coast, right? They don't want to live in the flat interior of Florida. They want to live on the ocean, and that's the most vulnerable place in terms of storms and property damage. All right, and then there's been an increase in the frequency of large hurricanes impacting Florida. So again, you're putting more people and more valuable property in places where they are being impacted by larger storm events. And that's a bad combination. If you really want to sort of get a sense of what's happening with property loss and the cost of climate disasters, go online and read documents produced by the insurance industry. Because the insurance industry, this is their livelihood, right? They need to be able to predict how much money they are going to lose any year, in any given year, because of climate-related disasters. And the insurance industry is discovering that they can't make accurate predictions because what happened in the past is not a good predictor of what is going to happen in the future because of climate change. And so there's a lot of concern in the insurance industry, and the insurance industry is trying to get out of markets where they feel like they're most at risk, including Florida. So a number of large insurance companies have basically tried to stop doing business in Florida. They don't want to sell homeowners insurance in Florida anymore because it's just too risky for them. And they don't know how much to charge. They can't predict how much to charge for an insurance policy because they just don't know the probability of having to pay out on those insurance claims. So I always like to look to the insurance industry for data on the cost of climate change. This is a really cool graph that was produced by the world's largest insurance company, Munich Re. Munich Re is an insurance company that insures other insurance companies. So if you're an insurance company, you take out an insurance policy, so if you end up having to pay more than you take in a given year, you can file a claim, right? So Munich Re puts out these reports on sort of, the year in weather disasters, in natural disasters, not just weather disasters. And this is a graph that they published in 2018 that shows different disaster events Flood events, climate events, storm events, that's yellow, blue, and purple. And then geophysical events. Geophysical events are not related to climate. These are things like volcanic eruptions and earthquakes, tsunami. And if you look at the graph here, there's a clear increase in the frequency, this is global, of all of the events that are related to climate. But interestingly enough, there's no increase in geophysical events, right? So if the increase in insurance payouts was due strictly to, say, increase in global population, increase in property values, it shouldn't matter what kind of event was happening, you should see an increase. But the fact that you see an increase in anything related to the Earth's climate, but you don't see an increase in disasters that are not related to climate, is telling us that the Earth's climate change is leading to more disasters. Those tables that I showed you before, where we added up, the total cost of disasters and number of events, I took those data and I made my own graph where I basically looked at by category of event over that whole time period from 1980 to I think it was 2018, which events were becoming more frequent, which events were becoming more costly, and were there any events that were becoming less frequent or less costly. And it turns out that there's no category of disasters that have become more costly but less frequent. All right, that nothing is happening less but costing more. The events that are happening less frequently and are costing less are events related to cold weather, freezes and winter storms. The events that are happening more frequently and are costing more are hurricanes, wildfires, and severe storms. And then droughts and flooding seem to be happening more frequently, but are costing less each time they happen. And I don't have a good explanation for why droughts and floods have decreased in cost per event. I just don't know. But the point here is that this is the pattern that you would expect in a warming world where events related to cold weather are becoming less frequent and less expensive, but events related to having more energy and more moisture in the atmosphere are becoming more frequent and more costly. Now, given, again, the trends in population and property value and everything, can we be sure that climate events are getting more frequent or more severe? That's what we predict from global warming with more energy and more water in the atmosphere, but is that actually happening? And the answer is yes. The data, even though we've only got a couple of decades of good data at this point, I think they're pretty clear. So I want you to look at the upper graph here, which is a graph that's plotting for any given year what percentage of all hurricanes that happen in that year were Category 3 or above. So hurricanes can be Category 1, 2, 3, 4, 5. So what percentage of all hurricanes were 3, 4s, or 5s? And there's 50% right there. So you can see that over time, larger storms have become increasingly frequent and on average, but pay attention to the peaks. So there's 2013 and 2024 where you had, 2/3 of all the hurricanes reached at least Category 3. Compare that to what was going on back in the 1980s when you had, in no year did more than half of the hurricanes reach those higher categories, right? So what this is showing is that hurricanes, they may not be more frequent, The data on whether hurricanes are becoming more frequent is sort of equivocal, but they're definitely becoming more powerful. And we've all seen that. We've seen how a hurricane now can go from a Category 1 hurricane to a Category 5 hurricane in 24 hours because it's crossing over extremely warm water in the Gulf of whatever you want to call it these days. The Gulf of Mexico. This is, and by the way, these data were produced by an insurance consultant using, or the graphs were produced by an insurance consulting company from data coming out of Colorado University. Here's some graphs that were produced from NOAA data by another reinsuring company, Gallagher RE, sort of like Munich RE. These are days with greater than 10 tornado reports. And again, there's a lot of up and down in the data, but the overall trend is increasing, and the peaks are becoming higher and more frequent in the 21st century than they were back in the 20th century. And the troughs are also higher than they were. So tornadoes are becoming more frequent. Hailstorms. And you want, what's the big deal about hailstorms? It turns out hailstorms cause an incredible amount of insurance cost because of cars, right? A big hailstorm will basically wreck everybody's car. So it's a huge payout. Hailstorms are definitely becoming increasingly frequent in the United States. We've already heard about heat waves, but here's another way to look at those data. This is the 20 deadliest heat waves in, around the world in history. Of the 20 deadliest heat waves, ranked by number of deaths, 3 of them happened in 2024, 3 out of 20. 11 happened between 2015 and 2024. 2005 to 2014, 1, 1995 to 2004, 3, and all the rest happened sometime before 1995. So you can see here that starting around 2015, tremendous increase in the number of heat wave deaths. And that's that threshold effect, right? That's that we crossed a line there, and now extreme heat is suddenly become a phenomena that occurs a lot more frequently, and extreme heat is deadly for people who have no way to get into air conditioning. Wildfires as well. We already heard about wildfires. I like this graph because it includes 2025, so the Los Angeles wildfires. Insured losses will easily exceed $30 billion. And another thing to notice is look at the dates. Almost every single one of these costly wildfire events has happened in California and in the 21st century, right? And why California? Well, most wildfires happen in the American West because it's more arid, and most people in the West live in California. That's where the high population densities are, right? And there's 2 things going on here. Again, it's a synergistic effect. You have climate change factors. You have this phenomena of whiplash weather. So why were the fires in Los Angeles so severe? Well, they had a really, really wet earlier part of the year, which caused a lot of plant growth. And then it went from really, really wet to really, really dry. What was supposed to be the rainy season didn't arrive. It didn't actually arrive until after the fires were pretty much over. So all that vegetation dried out and became fuel. And then it became really hot and really, really dry, and once the fires got started, they burned out of control. So hotter daytime temperatures and also hotter nighttime temperatures are especially important because at night, if you don't get cooling happening, then the heat just from the daytime just builds up. So whiplash weather combined with the hotter temperatures interacting with the fact that in the Los Angeles region, you have the population spreading out into the mountains around Los Angeles, which are very fire-prone areas. So you've got more infrastructure, more people putting themselves in harm's way, and then the harms are becoming more and more severe. And that's a bad combination. So again, if we just kind of look at sort of the data, right, on these climate-related catastrophes in the United States and how they have increased over time. All right, if we look at deaths, average number of deaths per year due to climate catastrophes in the United States, in the 1980s through the early 2000s, it was about an average of 300 deaths per year. And then in the sort of between the, say, within the decade of 2010 to 2020, average deaths per year pretty much doubled. And so we don't have the data for 2020 to 2030 yet. We're only about halfway through that. But if we look at the first 4 years of our current decade, the trend seen in the from 2010 to 2020 has maintained itself. The last 3 years, 2022 to 2024, a little higher, and then 2024, the highest yet. So things seem to be increasing. If we look at the average number of billion-dollar events per year, that started climbing at the end of the 20th century, but it really took off in the 21st century, and all indications are for the first 5 years of this decade is that trend is going to continue. Same thing with cost in billions of dollars per year. So this was number of events, number of billion-dollar events. This is cost, total cost per year. And again, all indications are that is just going to keep increasing, right? As those two factors interact, right? The shift in human population and the increase in property values combined with the increasing severity of these climate-related disasters. So a couple of take-home messages. Climate change is making natural disasters related to the Earth's atmosphere more severe and more frequent, so more dangerous, basically, as we head through the 21st century here. Trends in population growth, development, and economic prosperity are magnifying the destructive impact and cost of climate change on human society, right? And hopefully, some of those trends will continue. I like to think that we're going to, as a nation, continue to become more prosperous. We are probably going to continue the demographic trends of people moving, and wanting to live on the coast and all that. So there's no indication that any of these demographic trends are going to let up. They're going to continue. And there's no indication, in fact, the expectation is that unless we decarbonize our energy economy, climate change impacts, or climate change effects are just going to continue to become more and more severe. And so the interaction of those two things is going to continue to create more expensive and more deadly disasters. The goal of decarbonizing our energy economy, by the way, is not to reverse climate change, because the climate change that we have now is kind of baked into the system. It takes hundreds of years for carbon to come out of the atmosphere once we put it in the atmosphere. What we're trying to do is prevent it from getting any worse than it already is. Because what we're looking at now are trends that are rising exponentially, right? We're looking at accelerating trends. We want to slow those down. It would be great if we could stop these trends, but at least we need to slow them down, because the more time we have to react and to adapt to changes in the climate, the less costly and the less deadly it's going to be. We need to start to put the brakes on what the Earth's climate is doing because of our greenhouse gas emissions. All right. And finally, if you're going to do an accounting of the costs of a fossil fuel-based energy economy, you should factor in the costs of climate change-related disasters, right? Because it's the burning of fossil fuels that's causing the problem. So if ExxonMobil makes a certain amount of profit selling oil and natural gas, right, and they're not doing anything to reduce the emissions of carbon, those costs get passed on to all of us in the form of insurance payouts because of these climate disasters. So the companies that are selling fossil fuel are making money off of everybody else's suffering and misery, basically. And that's all I got. So,
Thank you so much. So we're going to do some questions and answers, but I want to say this to all of you. I know that was a lot of gloom and doom, you know, that we have fires, we have drought, we have more tornadoes, we have hailstorms that kill every car, we have insurance rates going up, home values going down, Fire Island, it's going to be history. So there's a lot going on there, isn't there? But remember, the course of history isn't written. It's what you do that matters, and that's the truth. We have a saying at our office: get up, show up, and speak up, because you really will make a difference. You don't have to be an activist, although that would be nice. You don't have to be doing the work full time, but you have to do something. Maybe you just do social media posts once a week about climate change. That would be great, especially our students here today. You should be doing those posts. I'm guilting you now. Whether it's Instagram or Facebook or whatever it is you're on, TikTok, do it on climate change. You heard facts. You heard science. It's real. It's going to impact you. You're not going to have a beach home. Well, if you're in the middle of Long Island, you might have a beach home in 15 years from now. But the truth is that even if you go on, CCE's social media, hit follow. Not just us. We have Renewable Energy Long Island is here. CTUC, the great people at AMCs are here who rescue all our marine animal species. Who am I missing? Okay, that might be it. But there's many local environmental groups that are present, they're active, and you could just follow them on social media and help them. The other thing is support offshore wind. There is a fierce backlash. It's concentrated in the city of Long Beach, who are a group of climate deniers. They disguise themselves as environmental groups, but they deny that climate change is real. They reject everything that Dr. Shepson has said, even though he clearly said there's no sides to this. The science is the science. They believe it's all naturally caused, and therefore we don't need offshore winds. And their point of view is the most reliable source of energy is the continued reliance on fossil fuels. That needs to be rejected. One of the things I think that is so important and so special about the human species is that we can adapt. We can change. But we can't change without public sentiment behind that change. All change happens and remains because the public understands it and supports it. So we need your help. We need your voice. Again, we're not asking you to change your life or do anything dramatic, but we are asking you, we're dubbing you all now ambassadors, to understand climate change is real and that we're going to need to make some changes. Some of them might be even inconvenient. I know we don't like to be inconvenient in our lives, but when we understand that there's a need for change and that it will lead to something beneficial and positive, I believe that people will do it. I still very much believe in the goodness of people, and I believe that people want a clean, safe, healthy environment, and that they are willing to change to achieve that goal. And I appreciate you guys coming because you've listened to a lot of facts and a lot of figures today. I really want to thank both our brilliant and wonderful speakers because it is through their work and their research and their message that we can invoke change, positive change for the future. So I really appreciate both of you, your dedication and the work that you've done. But let me pause and see if there's any questions from you guys for either of us. Your hand went up first, quick. Yes.
Bruce Agapinian from the Sierra Club. In recent months, there have been, among environmental groups, climate coalitions. I get an email here or there, but there doesn't seem to be a consistent flow of information about climate coalitions. Could you address that, please? Yeah,
there has been a change over the last 3 months in our federal government. We went from having a presidential administration that understood climate change was real, was willing to address it, was willing to support a transition in the way we produce energy. All of that stopped. All of that has been reversed. And so environmental groups, we honestly, we knew that would happen, but we didn't think it would happen so quickly and so abruptly. So now we're in the process, the groups across the nation, of forming these coalitions, working together and figuring out the most effective path forward. So bear with us a little bit. Remember, it's only April. We've only been in the current administration for 3 months. So I think you're going to see a lot happen over the next 6 months. There's a lot of organizing, and whether it's about climate change, even clean water. I mean, I got to tell you guys, I've been doing this work 40 years. Okay, you didn't have to raise your eyebrows like that. I'm kidding. Yes, and I started when I was 5. But I never thought, seriously, in the year 2025, I would have to stand up and say, we can't keep toxic chemicals in our drinking water. We have regulations right now on chemicals like PFAS and TCE that the current administration wants to roll back the standards and allow more in our water instead of getting out of our water. And if anybody told me 10 years ago, well, you're going to have to fight the same fight over again in 10 years because we will not have learned. We will capitulate to industry, and we will put profits above the public's health. We didn't expect that. So that's a very long answer. But basically what's happening is we are doing our own internal adjustments, adapting, but we are going to be fighting back. We are going to be continuing an agenda to fight climate change, transition to renewable energy, and really work to protect not the earth, as Dr. Bennington said, but the humans who live on the earth, all of you. So, question over there. Yes.
This is for Dr. Shepson.
Yes, Dr. Shepson.
You said something that took me back, and I know that Long Island is extremely vulnerable to climate change, especially Fire Island, but you put a timeline on that, and you had mentioned that it would be in the lifetime of the students. Do you really see that happening, or could you talk a little bit more about that?
Well, so there is a group of scientists who've been reporting to New York City about what we can do in terms of building resilience against change. And they did an analysis, essentially a model projection of the high end of what sea level rise might look like by the end of the century, with the argument that we should be aware of the high end of the probability spectrum of what we might face, in part because climate change has come faster than we had predicted. And so we need to be cautious. So the high end of sea level rise, as I recall from this group, is about 9 feet by the end of the century. And one of the things I like to tell people is the world does not come to the end at 2100. Civilization goes on and it will increase from there. But I think 9 feet, especially if a tropical cyclone impacts Long Island, there is no way that there will be any houses standing on Fire Island.
Cyclones hitting us.
I can give you a positive note about the previous question, is that local action can be really important and really successful. And I want to say something to there are high school students here, right? Raise your hand if you're a high school student. I want you to hear something important. You are powerful. You should be able to feel the power coursing through your veins. I'll give you an example. In the early 1970s, our country asked young people to go risk losing their lives in Vietnam. And Muhammad Ali, one of my heroes, said quite eloquently, "I ain't got no quarrel with the Viet Cong. I'm not doing it." And he was willing to go to jail. But young people fought this particular, what was believed to be a social injustice, and they put a stop to this war. It was college-age kids.
Yeah.
They banded together and stood up for what they thought was right. Let's not put any judgment on what was the right thing to do, but they expressed, we can change the course of the future. It isn't written. Anyway, the extreme side of the future is scary. So the point is not to scare us, but to inform us so that we can make decisions about how to build some resilience, how to invest more in renewable energy and less in fossil fuels. And that's a good idea for the United States, by the way. The future has to, period, has to rely on renewable energy. It will happen. So does the United States want to be on the investing, the leading, the innovative edge of what has to come? Or do we want to run with our arms wide open towards the 20th century? I hope not. We can't ever have the 20th century again. And so you might disagree with me, but I care about the United States. Unlike Adrienne, I like animals more than, especially my dogs. I like investing in all the things that are alive on the planet, especially the things that can't advocate for themselves.
I like animals.
I'm sorry. You said especially people. I'm not good.
I have a special fondness for people.
I do too.
How is that a bad thing all of a sudden?
Oh, I'm going to pay for this for years and years. Anyway, I hope I answered the question.
Okay, thank you. Over here, yes? And then did you have...
Question for Dr. Bennington. So you spoke about costs and what it is really costing everyone in the United States to, I guess, recover from these storms. Do you have some kind of report what it actually would cost, FEMA studies and FEMA costs on top of insurance costs, and what it would cost, I guess, each individual or taxpayer within this country?
I don't know. I don't know if anybody's attempted an accounting like that. I mean, it would be worth doing, I think, because, if you're trying to make policy decisions, you need to know, which policy direction will incur the most cost, which will incur the least cost. And that's, I know there's been a debate over, is it more economically viable to continue with the energy economy we have and let climate change happen and adapt to it as it happens, or would it be better to invest in alternative energy and prevent climate change? Given the uncertainties of the rate of climate change, I I would not want to bet on our ability to continue with business as usual and adapt to what comes. I think we would be much smarter to forestall climate change as much as we can, because it's already imposing huge economic burdens on the country. And there's nothing to suggest that it's just not going to get exponentially worse if we don't do something about it.
It's not going to fix itself.
Are the insurance companies and the reinsurance companies lobbying for alternative
Interesting
energy?
question.
I don't know. That's a good question.
I haven't seen them in the halls of DC or in the halls of Albany where we are. So for people who didn't hear the question, he said, well, are insurance companies lobbying for renewable energy? Which would be a smart thing for them to do. But we haven't seen them. We do a lot of work in Albany. I just got back from there Tuesday night again. We do a lot of work in DC, and we have not seen any evidence of insurance companies lobbying for renewables. Good question.
My sense is they're more concerned about trying to figure out which markets to get out of.
Yeah. Yes.
About the impending doom of Fire Island, where would that leave Long Island in like a little bit more time than that?
So that's a great question.
Very
All right.
good question.
Long Island's been here for about 20,000 years, right? It's a big pile of sand that was left behind at the front of the glacier that came down from Canada. And
Is
then,
where his geology comes
yeah,
from.
this is you asked a geology question to a geologist, so buckle up. So Long Island's a big pile of sand that was dumped here about 20,000 years ago. It is washing away. The ocean is washing Long Island away at a rate of about a foot a year. So that's, I mean, the average rate at which the shoreline is being eroded away is about a foot a year. So, you know, I mean, you can do the math, but Long Island probably isn't going to be around for much longer than another 10 or 20,000 years, right? As sea level rises, the rate at which the shoreline erodes will increase. So the North Shore is going to retreat towards the center of the island. The South Shore is going to retreat towards the center of the island.
I told you you'd have waterfront property if you live in the middle.
If you wait long enough. The barrier islands, like Fire Island, what they're trying to do is move with the sea level rise. That's what barrier islands do. They essentially roll over. So storms pick up the sand from the ocean side and dump it on the bay side, and as sea level rises, the island will kind of move along with the sea level rise as the south shore of Long Island retreats. The problem is we build stuff on Fire Island and the other barrier islands, and we don't want the island to move out from under the things we've built. So what we try and do is when there's a storm that moves sand from the ocean side to the bay side, is we pick up the sand and we put it back on the ocean side.
That's exactly what we do.
And, you know, put that property back, but it's unstable there, and the next storm that comes along is going to move it, and it's a losing battle. So Fire Island isn't going to completely disappear. Parts of Fire Island, which are the natural parts of Fire Island, will be able to migrate, but the developed parts of Fire Island are going to sink underwater eventually, because those parts, we're not letting them go anywhere. And it's going to become a huge problem for places like Long Beach, where you have a tremendous amount of infrastructure, and we're going to end up, you know, building seawalls and doing things to protect that infrastructure from flooding, because it's just not feasible to move it anywhere. But eventually there will come a reckoning, I think,
Did you want to
because
chime in on that?
I want to just add a little bit to both of the last two questions. So I think any structure that is within 10 feet of sea level is certainly at risk. I didn't mean to pick on Fire Island. There are lots of homes at risk all around Long Island that are much even closer than 9 or 10 feet. I wanted to make a comment about the previous question about is the insurance industry advocating for renewable energy. I thought your answer is probably spot on. I certainly don't know. But I am aware of an organization in the United States that has consistently, over the last roughly 45 years, advocated for renewable energy and combating climate change. Consistently, anyone know who it is?
CCE? Oh, no.
Department of Defense has been consistently supporting investments away from fossil fuels
true.
and toward renewable energy because the Navy has a lot of property on the coast. And so all of that property is at risk. We have to rebuild our naval shipbuilding and the ports that are home to all of our defensive vessels. They know, actually, for decades, everyone, including ExxonMobil as an example, knows about climate change.
That's right.
It's just, what part of the world you live in and what you want to advocate for and why, and it's usually about money. That's just the nature of civilization. We care about our wealth. But ExxonMobil has had the ability to hire the best and the brightest with the greatest salaries.
Yep.
And they've known for 50 years.
And we have documents illustrating that they knew. And those documents were hidden. And they were saying, look, I just got to say, this is not rocket science, all right? You burn a fossil fuel, carbon dioxide goes in the atmosphere, and carbon dioxide absorbs heat. The more carbon dioxide, the more heat. Not rocket science. Oil industries knew, whether it was Shell Oil, ExxonMobil, BP, they all knew. They hid it because it was an inconvenient truth. Now, there's been lawsuit after lawsuit that they should pay for the damage of climate change because they knew and because it's documented that they knew. Let's be clear. I just want to say one other thing about Fire Island, and please correct me if you think this is not correct. I also have a geology degree. But if Fire Island wasn't there, it is the first protection for I'll call it the mainland, but Fire Island doesn't like when we say that because they consider themselves part of the mainland, and I get that. Would be way more vulnerable to floods and storm surges and high wind events and whatever else is coming our way, hopefully not typhoons, but it was mentioned. But it makes us even more vulnerable without that first barrier island of defense. And that is of concern as well. So I think that's maybe what you were asking, like what happens to the mainland if Fire Island becomes inundated with floodwater. But okay, one last question. Well, we'll do two more. You and then you. Okay.
I just wanted to say, I just looked it up, and right here, we're about 16 feet above sea level.
In Babylon, we're at 16 feet. Okay.
Yeah.
In case you want to know that, we're 16 feet above sea level.
16 feet. So you take that 9 away,
Right.
and it's going to happen little bit every year.
Yes.
You may want to.
9 feet is actually a lot. Okay. Yes, I'm sorry.
Just had a question about the figures you presented today. So it's been well documented that global supply chains have had negative impacts on renewable energy efforts out here, wind energy, the war in Ukraine, all of that. How much of that is impacting the figures you showed today? And do you see that being an issue in terms of just traditional storm recovery, getting materials to kind of respond to some of that?
Getting materials to respond to storm recovery? That's more for you.
Well, if global supply chains are disrupted, then the cost of recovery is going to go up, which will make these events more expensive. I mean, I don't see any other way around it, really.
Yeah, I think the geopolitical circumstances will only make climate change impacts worse. They will not make them better. The problem is not going to solve itself, right? So, okay, we have two more questions. Okay, wait, I promised some. Yeah, okay, but you, and then we'll close. Okay.
Thank you. My name is Odessa Watson. I'm the director of the Office of Minority Health for the County Health Department. And I just attended a forum on climate and faith, and one of the conversations that came up is that yes, we're all going to be impacted by climate change, but underserved, under-resourced communities are often impacted by climate change and environmental justice. So I wanted to know from all of you, are you working on any local projects to galvanize community members around the basic understanding of climate change and what we can do? And is there a way that the health department can also work alongside you?
I'll just start. So I'm impressed by and inspired by New York State that wrote the Climate Leadership and Community Protection Act that requires that the investments that we make in mitigating climate change and investing in a new renewable energy economy, that for at least 40% of that money should go to frontline communities. To invest in things like making sure that people have a way to get away from or be protected from extreme heat events. And Stony Brook University led the successful competition to create the New York Climate Exchange, which is about being in partnership with New York City and an awful lot of what they want to do. I'm not a part of that, but I know about what they're intending to do. And that is working with community groups to protect at-risk communities. So what you're talking about is extremely important. You know, it's the low-income people who don't own a giant house that is well air-conditioned that we need to worry about it and care about it and invest in and protect. And then there's also the workforce training that is part of that legislation and the New York Climate Exchange, that people are able to be a part of the local, state, county, national investments in a renewable, healthy future.
And I know Hofstra University's partnered with Cornell Cooperative Extension on a New York State funded project to basically help underserved communities kind of connect with opportunities for renewable energy and to help them, become aware of how they can, get rebates for solar and energy efficient appliances and things like that.
And also, I'll say, Citizens Campaign for the Environment, we just launched our climate education program where we've reached out to numerous colleges and civic groups, and we were at, Lindenhurst Library last week doing a presentation. We're here today. We have a number of libraries scheduled. Christina is in charge of that. She's over there, wave. So we're doing a resurgence of climate education on a grassroots level so people can understand what it is, that it does cost money, it does impact us, and what do we need to do to get engaged and involved. So, and I know that groups like Rely are doing a lot on such as energy efficiency programs for the homes and giving people access to funding for that and tips on how to have access to that. So I think we're all kind of working in the space and trying to do what we can. Okay, you're going to get the last word, or not the last word, but the last question.
Sure. I wanted to ask, how do you address debates or challenging questions as far as renewable energy is concerned? Specifically, like for example, I hear that you are just shifting the problem to another environmental justice area, for example, dealing with like battery storage sites or even like mining for like the coal battery or lithium, how to dispose of it. We understand that change has to be done, but how do you address these questions with like the general public?
I'll tell you how I do it. I'll go first. Because we get these questions all the time, and we tell people there's no large-scale energy generation that's perfect. And there's no large-scale energy generation that doesn't have some impact to the environment. But I have to say, sometimes, I find it ironic, and I'm just going to be honest, that those same people who say that, there's a lithium battery in your laptop, there's a lithium battery in so many things now. The only problems they have with lithium batteries is, when it has to do with something in the renewable area. So we, as technology develops and evolves, we're impacting the earth. our role right now is to analyze it all and figure out the least footprint, the least impact. And that's what we support. You know, I get all sorts of questions about wind power. Well, I'm sorry, how do you support wind power as an environmental group if the blades aren't recyclable? I'm like, nobody ever stood up at a meeting and said, is the Port Jeff power plant recyclable? How about the Northport power plant? Are we recycling that? No one ever asked that. They have these very high, bar for renewable and 0 bar for burning fossil fuels. So I have to say, well, first off, there aren't any excess turbines right now, blades, that we can recycle. So the market's a little stunted. You can't, but the good news is scientists are actually looking at how to reuse that composite in a constructive, productive way. So as these technologies evolve, just like any technology, some high school kids won't remember this, but when they first came out with cell phones, they were as big as a shoebox, all right? And you carried it around in Albany like this. Now I can't even find mine in my purse. It's so small. So why? The technology evolves, the cost went down, everyone has it. Wind, solar, and other renewables that are yet to come on the market, the same thing will happen with them. So I just want to say, we do get those questions a lot. I answer people as honestly as we possibly can. Humans leave a footprint on the planet. Our technological needs leave a footprint on the planet, but we don't have to leave craters. And right now, fossil fuels are generating craters. Like, I can see his hand moving onto in the corner of my eye.
I'm just afraid that you're going to bring it to a close.
No.
So 2 things I want to say about this. Really good question. I think we need respectful discourse, that we should care about everyone in society. Everybody's important, and we ought to express that. Everyone is important, including your opinion. If you're expressing an opinion, it means we've got your attention and you care, right? You're expressing your civic duty, and you're definitely doing that when you disagree with me vehemently. It's good. So I would always start the answer to that question, whatever it is, with good question. Let's talk about that, and then turn it over to Adrienne. I want to say something about this. What we've been talking about is local community action. As I said, it's really powerful. I'm really inspired by Adrienne and what you're doing here. She is an expression of what we can do locally on Long Island. We're all here because of the efforts of that one group, and it's impressive, and we should do more and get behind it.
Thank you. So again, thank you so much for coming. I hope you learned a lot. Like and follow us on social media posts, and we'll see you guys in the near future.